Hey Geometry, we are continuing on with our congruence criteria for triangles. Today we're going to do ASA and SSS. ASA stands for angle, side, angle, and it has to be in that order where side is between two angles. That means the side is included. And then SSS, which you guessed it, is side, side, side. Okay? All right. Use the provided 30-degree angle. It'd be fun if we had paper in front of us, then we could do this a little bit different, as one base angle of an isosceles triangle. Use a compass and a straight edge to construct an appropriate isosceles triangle around it. So we were taking this 30-degree angle, and first we're going to copy it, and then we're going to copy it again on the other side of the first one. So I guess reflect it and copy it. And what do we come up with? Compare your constructed isosceles triangle with a neighbor's, which is near impossible. Does using a given angle measure guarantee that all the triangles constructed in class have corresponding sides of equal lengths? This means that if you made one and your neighbors made one, your neighbors may have made one with the same 30-degree angle, but maybe this bottom was a lot longer than this one, or a 30-degree angle where these are both 30-degree angles, but this bottom, this base, is much shorter. Okay, so everybody's is not going to be exactly the same. Okay, giving two angles that are equal does not mean that the triangles are equal. Okay? All right, so today we're going to examine two more triangle congruence criteria: the angle side angle, ASA, and side side side. To add to the side angle side criteria we've already learned. Let's start with ASA. Okay? The angle side angle triangle congruence criteria, we can just call it ASA. Given two triangles, triangle ABC and triangle A prime B prime C prime, if the measure of angle CAB is equal to the measure of angle C prime A prime B prime, so we have CAB and C prime A prime B prime, so those are two equal. So we have two sides. Those were our two angles that were congruent. We have sides that are congruent and two more angles that are congruent, then the triangles are congruent. Okay, proof. We do not begin at the very beginning of this proof. Revisit your notes for the SAS proof where we translated, rotated, etc. Revisit your notes for the SAS proof and recall that there are three cases to consider when comparing two triangles. In the most general case, when comparing two distinct triangles, we translate one vertex to another. That's what we did first. Choose the congruent corresponding angles. Remember, we had two triangles, and we took the A and the A prime, and we translated one to the other. Right? Those are the corresponding congruent ones that we translated. A rotation brings congruent corresponding sides together. Since the ASA criteria allows for these steps, we begin there. So we have angle, side, angle, equal angle, side, angle. Okay, I put a picture up there again. Let's read through it. In order to map triangle ABC prime to triangle ABC, we apply a reflection across line AB. Okay, so there's our reflection line. The reflection maps A to A and B to B since they are on the line AB. However, we say that the reflection of C triple prime equals C star. They ran out of things to use. Though we know that the reflection of C triple prime is now the same half plane of line AB as C, we cannot assume that C triple prime maps to C. So we have the reflection of triangle ABC triple prime equals the triangle ABC star. Okay, we can't assume that C triple prime maps to C, so we've renamed it into a new one. excuse me, and we have the reflection of triangle ABC triple prime equals triangle ABC star. To prove the theorem, we need to verify that C star is in fact C. By hypothesis, that means we're making an educated guess. We know that angle CAB is congruent to angle C triple prime AB. So CAB is congruent to C triple prime AB. Sorry, CAB, C triple prime AB. I did that backwards. Recall that C triple prime AB is the result of two rigid motions of C prime A prime B prime, so must have the same angle measure as angle C prime A prime B prime. This is from previous proof. Similarly, angle CBA is congruent to angle C triple prime BA. Since angle CAB is congruent to the reflection of angle C triple prime AB is congruent to the angle C star AB, and C star are in the same half plane of line AB, we conclude that ray AC and ray AC star must actually be the same ray. And if you remember, that's how we define angles, as the joining of two rays. Because the points A and C prime defines the same ray as ray AC, the point C prime must be a point somewhere on ray AC. Using the second equality of angles, angle CBA is congruent to the reflection of angle C triple prime BA is congruent to the angle C star BA. We can also conclude that ray BC and ray BC star must be the same ray. Therefore, the point C star must also be on ray BC. Since C star is on both ray AC and ray BC, the two rays only have one point in common, namely C. We conclude that C equals C star, which is very important. That's the goal. We've now used a series of rigid motions to map two triangles onto one another to meet the ASA criteria. Phew. All right, let's do side, side, side. The side, side, side triangle congruence criteria. Given two triangles, triangle ABC and triangle A prime B prime C prime. If AB is equal to A prime, B prime. No, sorry. I have to move this down a little bit. There we go. I couldn't see it. Given two triangles, triangle ABC and triangle A prime, B prime, C prime. If AB is equal to A prime, B prime, which is a side, AC is equal to A prime, C prime, which is another side, and BC is equal to B prime, C prime, which is the third side, then the triangles are congruent. Okay, that's the theorem. Proof. Again, we do not need to start at the beginning, but assume there is a congruence that brings a pair of corresponding sides together, namely the longest side of each triangle. Okay, when side equals side, side equals side, and side equals side, then the triangles are congruent. Without any information about the angles of the triangles, we cannot perform a reflection as we have in the proofs for SAS and ASA. Okay, that's where we did a lot of rays. So to do the proofs for those, we looked at angles and proved that the rays were congruent. So how do we do this? First, we add a construction. Draw an auxiliary line from B to B prime and label the angles created by the auxiliary line as R, S, T, U. Okay, it's up here now. Since, hold on. Sorry, it's very hard for me to see. It's under my controls. There we go. Since AB is equal to A prime, B prime, and CB is equal to CB prime, triangle A, B, B prime, and C, B, B prime are both isosceles triangles respectively by definition. Therefore, R equals S, because those are base angles of an isosceles triangle. And U equals T. Cool. Where are we? R equals S because they're base angles, and isosceles triangle, A, B, B prime. Similarly, the measure of angle T and the measure of angle U are equal because they are base angles of triangle C, B, B prime. Therefore, triangle ABC, right here, equals the measure of angle R plus the measure of angle T plus the measure of angle S plus the measure of, ABC equals the measure of angle R plus the measure of angle T equals the measure of angle S plus the measure of angle U equals the measure of AB prime C. Since the measure of ABC is equal to the measure of AB prime C, we say that triangle ABC, the whole triangle, is congruent to A prime, B prime, C prime by SAS. Okay, I'm going to say that again. R is equal to S, and T is equal to U. So R plus T is equal to S plus U. Okay, that would be our addition property of equality. So we can say that this angle is equal to that one, and I've got side angle side and side angle side. So we've already proven side angle side. We can use that to prove side side side. But let's get into it now. I've drawn lots of stuff here. Okay. We've now used a series of rigid motions in construction to map two triangles that meet the side-side-side criteria onto one another. Note that when using the side-side-side triangle congruence theorem criteria as a reason of proof, you need only state the congruence and side-side-side. Similarly, when using angle-side-angle, you need only state the congruence and ASA. Now we have three triangle criteria at our disposal. There we go. We use these criteria to determine whether or not pairs of triangles are congruent. Exercises. Okay, we have a few exercises. I want to make sure you guys know how many so you know what you're getting into. There are 5. They are not proofs though. Everyone cheers. Yay, they're not proofs. Based on the information provided, determine whether a congruence exists between the triangles. If a congruence exists between triangles, or if multiple congruence exists, state the congruencies and the criteria used to determine them. Okay, so we know M is the midpoint of HP. Midpoints mean that I can mark two things congruent. And the measure of angle H equals the measure of angle P. H equals P. This is when you look at your diagram and you think to yourself, what else do I know? Okay, we're looking for ASA, SAS, and SSS. Those are our options. Well, I know that those are congruent because they're vertical angles. Let's get 2 arcs there. Okay, so I can say triangle GHM is congruent to triangle RPM because of angle side angle. Sorry, I got interrupted there. Angle side angle, which you see I have angle, included side, angle. Angle, included side, angle. There's 5 exercises. I think I said that out loud before. So, okay. Rectangle JKLM with diagonal KM. I'm trying to find some triangles that are congruent. So let's mark the things that we know. It's a rectangle, so I can say those 2 are congruent. Those 2 are congruent. And whenever I have 2 triangles that share a side, we can always mark the side they share as congruent, because KM is part of 2 triangles. It's part of triangle JKM and LMK. So here I can say that JKM is congruent to triangle LMK. You need to name them in the right order. Please notice I went JKM, LMK. So those 2 are congruent because of side, side, side. I could also say these angles are congruent. So I could use side angle side, right? Side angle side, side angle side. I could also use angle side angle. When you have diagonals cut, because these are also parallel, correct? So I have some alternate interior angles. I need a different color. I can say these angles are congruent and those angles are congruent. So I could use angle side angle. So these are congruent, and I could pick any one of these reasons as to why they are. Okay, number 3, given RY equals RB, let's mark it. So RY equals RB, and AR equals XR. Okay, I see an isosceles triangle there, so I'm going to mark some base angles. I didn't even look to see what I'm trying to prove yet. Sorry. Oh, I'm just trying to find triangles that are congruent. Let's see. Ooh. I also know that those are congruent to each other. So I'm actually going to try to separate out these two triangles and see if you can see it. I have A, B, Y. That's a Y. Okay, I marked that congruent, this congruent, and I had 1 dash and 2 dashes, which if I add those together, they would be congruent. Let's see if I can separate the other one. Okay, so I've got 3 hashes there, an arc there, 1 hash, oops, 1 hash down here, and 2 up here. And let's label it X, B, Y. Do you see the 2 triangles that are congruent? Let's name them. I have triangle ABY is congruent to triangle, name them in the right order. I want ABY, so I need XYB. And to me it looks like side angle side is my reasoning. I could also say that triangle ARY is congruent to triangle XRB because of side angle side, and let's point that one out. I have ARY is congruent to XRB. Let's see if I can shade that a little bit. Okay, this triangle is congruent to this triangle, especially because I have vertical angles right here that are congruent. So it's side angle side. How fun. Okay, another one. Given the measure of angle A is congruent to the measure of angle D, let's mark it. And AE is congruent to DE. Let's see what we can prove. Well, I see here I have some vertical angles. Okay, right there and right here. So let's see if we can name those triangles. Triangle AEB is congruent to triangle DEC because of angle side angle. So that one works. Okay, last one. Number 5, given AB equals AC. Those are always hard to mark. So the whole side equals the whole side. BD equals 1/4 of AB. And C equals 1/4 of CE. So these are congruent. They're just telling you in a silly way. Let's see. So we know if the 2 sides are congruent, then the base angles are congruent. And I can say that the base is congruent to itself. What's cool, we know that AB, let me highlight it, AB is congruent to AC, and DB is 1/4 of AB, and EC is 1/4 of AC. That also means that this is congruent to that, which is pretty cool. All right, so let's see what else we know. Okay, this one was pretty tough for me to see. Let's see if I can draw it. A, E, B. Okay, we know that got 2 ticks, 2 ticks, 1 tick. and angle A. Let's draw the other one. That's pretty stinky. Let me try one more time. A, this would be D and C. So A is still congruent. I have 2 ticks, 2 tick and 1 tick. So what I really see here is side angle side and side angle side. So let's see if we can name it. Triangle DAC is congruent to triangle, I went DAC, so EAB, because of side angle side. Phew. All right, so that was really it. The things we've learned are side angle side. The side has to be included between the 2 angles, can't be on the outside. And then we learned side, side, side. And you don't have to do any proof to say that 2 triangles are congruent by those 2 methods. You just show the corresponding sides and angles are congruent and state your statement, which is very exciting. Good job today.